Alrighty, so we are ready to dive into actually factoring quadratics now that we know how to fill in the magic snowflake. Remember that the term factor, the idea of factoring is just the idea of breaking something down into its parts. So like if I said factor the number 6, right? You would of course know that 2 times 3 is 6, right? And we don't put the x because now we're in, in algebra or beyond, and so the x, represents a variable. So we put things in parentheses. 2 times 3 is 6. And of course, sometimes we can break things down into more than 2 factors, right? Because 4 times 3 is 12, but of course 4 is 2 times 2. So in this case, 12 has 3 factors, not counting 1 times 1, because that doesn't really do anything in this case. All right? So in the same way that 6 is 2 times 3 and 12 is 4 times 3, which is 2 times 2 times 3, we know because we learned how to multiply polynomials, we know that x squared plus 5x plus 6 is x plus 2 times x plus 3, right? We practice multiplying these two to get this. Now we're going to go the other way. Factoring is going from this polynomial, this quadratic here. I haven't defined quadratic, and I apologize for that. Quadratic is when the highest exponent is 2, in this case x squared. X is the variable, 2 is the highest exponent. There's an invisible exponent of 1 here that we don't have to write, but the highest exponent is 2, and that's what quadratic means. Alrighty, so we're going to work on factoring this to get this. So, first, we need to think of this in terms of a general quadratic form. The general form is ax squared plus bx plus c. It's just this with variables in the front instead of numbers. And we need to define a, b, and c, okay? So in this case, right, if we have x squared plus 5x plus 6, you can see that a is in front of the x squared. In this case, a is 1. b is in front of the x. In this case, b is 5. And c is the constant. Doesn't have a variable. So c is 6. No big deal, right? Okay. Then, this is where the magic snowflake comes in. We fill in the magic snowflake with some numbers, okay? On the top here is where we put a times c. And on the bottom, we put b. Remember how I said before that we're going to use these later? Now is the time. We're going to put a, and then whatever variable, in this case it's x. So we're going to put x and x, okay? And then we fill this in. So this is the general format. In your notes, you want to write this down. You want to write the general format down, okay? So write this down. On the top is a times c, and the bottom is b. And this is ax, and this is ax, okay? So, I'm going to scroll down here. Oops. Okay. Now, again, we have a, b, and c. We're going to fill this in specifically for this problem. All right? So, a times c, 1 times 6 is 6. b is 5. Here, a times x, not with the square, just a times x, 1 times x is x. So, now we fill in the magic snowflakes. What times what is 6 that adds to 5? Obviously, it's 3 times 2 is 6, 3 plus 2 is 5. Now, this last step, we take a look at this section here, and we think of it as a fraction. Can we simplify x over 3? No, we can't. Can we simplify x over 2? No, we can't. So we just write it out as x plus 3, x plus 2. Now, that last step where I talked about simplifying, frankly, when a is 1, you're never going to be able to simplify it. But sometimes there's going to be a number here, a coefficient, and you're going to simplify this fraction. That'll come later in the lesson. okay? So this is how we got from here to here, okay? Now, I'm going to do one on the left side of the screen, and you're going to do one on the right side of the screen, or in your notes, okay? So, let's try this. If I have a problem that looks like p squared plus 10p plus 21, and I want to factor this quadratic, okay? You have a problem that looks like this, m squared plus 14m plus 33, okay? So I identify A, B, and C. Okay, go ahead and identify A, B, and C for yours. Pause if you need to right now. Okay, so your A, B, and C should look like this. Okay, now watch again how this works with the magic snowflake. On the top, A times C, so I have 21, and on the bottom is B. And here I have 1 times P, so I'm just going to write P. Okay, go ahead and fill in your magic snowflake here. Pause if you need to. Okay, it should look like that for you. Okay, and then we think in our heads, what times what is 21 that adds to 10? Nice and easy. 3 times 7. Can I simplify either of these? No, I can't, so I write out the answer. Don't forget to write out the answer. Sometimes students forget that the point of factoring this is to get to, in this case, 2 binomials, right? So p plus 3 times p plus 7. This is the work to get here. This right here is not the answer. Right, so go ahead and find your answer for yours. Pause if you need to. Alright, so what times what is 33 that adds to 14? 11 times 3. So you have m plus 11, m plus 3. Easy, right? Okay, so we're going to do a few more practice examples. Okay, we'll just go down to this next page here. Okay, so if I have something that looks like this, v squared minus 49. Okay, think in your head, what is A, B, and C? So, A is in front of v squared, that's 1. C is the constant without the variable, so that's negative 49. What's B? Well, you could think of it like this. This is the same thing as v squared plus 0v minus 49. So B is 0. Okay? So then see if you can go ahead and finish this one out. Okay, check your work. Pause if you're not quite done. Notice that this is the difference of 2 squares, so you know that these are going to be the same, except one's negative and one's positive, because they have to add to 0. So you have v plus 7, v minus 7. Alright, try a difference of 2 squares on your own here. Q squared minus 81. Go ahead and pause and try to finish that one. Okay, and you should have gotten q minus 9 times q plus 9, just like that. Alright, now we're going to do just a couple more here where a is greater than 1. It's a little bit more complicated, but as long as you follow the rules of what we've talked about, it's the same type of thing. So if I have something that looks like this, 2c squared plus 5c minus 12, okay? You have, your problem is going to be 3a squared, whoops, put cubed there, 3a squared minus 2a minus 8. Okay, so I'm going to do mine here, oops, b equals 4, c equals negative 12. And notice how I fill this in. A times C. Notice the top isn't negative 12 because it's 2 times negative 12. So the top is negative 24. The bottom is 5. Notice here is 2 times c. Okay, so what times what is negative 24 that adds to 5? Let's see. Negative 24. It's going to be a negative here, and a positive. The bigger one's positive. So we have 12 and 2, but that's not it. We have 8 and 3. Oh, that's it. There we go. Negative 3 and 8. Okay. Now, we don't write out the two binomials because we want to see if we can simplify this fraction. 2c over negative 3. Can I simplify that? No, I cannot. So I write 2c minus 3. Okay, here, 2c over 8. Can I simplify that? Yes, I can. Think of it as a fraction. I can divide by 2. Divide by 2. So that's equal to c over 4. You see that? So in the same way, now we write this is c plus 4. This is a positive here, so it's plus. Okay, so here's our binomial. Now remember, you can always multiply this out and check to make sure it multiplies to get to this. Okay, you can always do that. Go ahead and try to factor yours just like that one. Pause if you need to, because I'm about to put the answer up. Okay, so here is the work. Notice that the 3a over negative 6, I can divide by 3 with each. So it's a minus 2. And then this I couldn't simplify, so it's 3a plus 4. Okay? So we are going to just have 2 more quick practice of these more complicated ones. I'm going to write the problems up here, and we're going to give it a shot. Go ahead and factor each one of these. Okay, pause and give it a shot. All right, check your work right here. Again, don't forget for a test, I would really recommend multiplying this out to make sure it gets back to your original polynomial, your original quadratic. Alrighty, so I hope you learned a thing or two. We'll see you next time. Toodles.